Welcome to the first episode of the Thinkers and Makers podcast. This is my conversation with Daniel Cremers. Daniel's a professor of computer science at TU Munich and a world-renowned researcher in the field of computer vision. He's also had incredible success with startups as co-founder or advisor. Some of the startups he worked with have gone on to be worth over $1 billion. Daniel's also a great mentor. His PhD students went on to be hugely successful. Many of them are now professors of their own. I also got the chance to see that quality in him firsthand. When I approached him, I hadn't uploaded a single episode of my podcast, and he still took the time to talk to me over Zoom to see what I wanted this project to be. He then met with me, recorded the episode for almost 2 hours, and then we even had lunch to discuss various other ideas we had. I hope you enjoy this conversation. If so, please like the podcast and subscribe. And now, please enjoy my conversation with Daniel Cremers. Hello, Daniel. Welcome to the Thinkers and Makers podcast.
Hello, Friedrich. It's a pleasure to be here.
So my first question would be, how much of a thinker and how much of a maker are you?
That's a good question. I've always seen myself more as a thinker. I started with studying mathematics, theoretical physics, did a diploma in theoretical physics, then moved on to computer science. But while I've seen myself more as a thinker, and I'm now in academia spending a lot of time thinking about things, it turns out I do have a maker side as well. First of all, I'm always fascinated by makers, but moreover, there are people, including my parents, who always seem to have seen me as a maker as well. So here's a story. When I got my PhD, my parents came to celebrate, and then when we were cheering with sparkling wine, my mother said, you know what? Your dad and I, we've always thought you would do something completely different in your life. And then I said, what do you mean, completely different? And then she said, well, you know, you're in a very theoretical field now, but when you were a kid, you always loved to do things with your hands. And so we always thought you would do something more practical. And so then I said, Mom, you do realize it's a little bit late to tell me now? And then she said, no, you're happy with what you're doing, so it's all good. But it turns out people did see a maker side in me, and I see that myself now increasingly. After years in academia, I'm getting increasingly excited by startups, by company developments, and I've created quite a number of startups, founded startups, served as advisor to startups, and I do like that side of my work very much, because I think it's important not only to develop new things, but also to somehow assure that these things will have a positive impact on our world, on our society, and help mankind kind of thrive.
Yeah, that's super interesting. So your mother maybe foreshadowed the future of your career, which is wonderful. So maybe let's try to understand what got you where you are. And let's start at the very beginning. So you mentioned you studied physics, and I know for a fact you studied physics in Heidelberg. Could you maybe tell us a bit about why did you decide to study physics, and why did you choose Heidelberg as a university to study physics?
So I should say I'm probably one of the first generations who was touched by computers. I had a Commodore 64 when I was a teenager, and it amazed me, and I always, very early on saw as a teenager this potential sleeping in computers, the potential that they can process things and do things super fast. Like the first computer code I wrote said like print Daniel, and then line 20 in BASIC you could still do go to, so I said go to 10, right, and went back, and then you execute this super simple program, but I was completely blown away because it could write Daniel so fast that I couldn't even process. And even a super, from nowadays perspective, lame computer was, overwhelming for me.
What age were you when you had your first experience?
Maybe 13, 14, right? And then I realized what potential was looming there. And now I'm in the field of artificial intelligence, right? And for me, it was clear that someday computers would beat humans in chess. Why? Because even on the Commodore 64, I had a chess program that beat me on level 2, right? And I never went up to level 7 because it was, it's hopeless, right? And then I realized these machines will become more powerful, and it will only be a matter of time until the best human chess player will be beat. And so that fascinated me, this capacity of machines to solve sophisticated problems. And so initially I thought I would go into computer science, but then they said the best computer science department is allegedly in Saarbrücken. And I was living in Saarbrücken at the time, and at the time, I wanted to move on. I didn't want to stay in Saarbrücken, so one reason why I didn't go into computer science was that the allegedly best place, was the place I was living in, and I wanted to go somewhere else. I didn't want to stay at home. I wanted to move on. This kind of a bit of a restlessness, this need to explore the world. I think it's always been with me from very early age, and so this was one reason why I didn't go to computer science. I think in retrospect, there's other good departments that are of equal quality as Saarbrücken, like Karlsruhe or also, the TU Munich is a top computer science department. But at the time, the other reason why I didn't go into computer science initially was I wanted to teach machines how to understand the world. And that requires to get a clear picture of what does it mean to understand the world. And understanding the world, for me, is very much what physics is all about. How to cast the world and the phenomena we observe into mathematical descriptions and equations that allow us to create predictions of how things will move, how things will evolve over time. And what I do now is very much trying to teach a machine to gather that understanding about the world around us. And in my view, this is one of the biggest challenges nowadays in the field of artificial intelligence, teaching a machine to understand the world, teaching a machine to see things, to predict how things will evolve and change over time.
So one could say, even though you're a professor of mathematics and computer science, maybe in some ways you're using different tools to do the same thing you did when you studied physics in Heidelberg.
Yes. I am a professor of computer science and mathematics today, but I always say if I had a choice to start over, I would always study physics. Because for me, physics is a discipline where you learn a lot of mathematics, but at the same time, you learn how to apply mathematics to model reality. And this is, I think, something crucial to develop intuitions, which mathematical tool is the right one to model which phenomenon. And there is a huge toolbox of mathematics, from differential geometry and group theory to algebra and discrete mathematics. And the question is, and partial differential equations, etc. And the question is, what is the best tool to solve a certain problem, to model a certain phenomenon in the real world? And I think this is something that physicists typically learn.
So maybe that's the heart of what you do. You use the tools of math and physics to model the world. In another conversation I heard, you told the story how you were writing your master's thesis in theoretical physics and then had an interaction with your mother that shaped your career. Can you maybe tell us about that?
Yes. So interestingly, my parents did have some impact. When my mother, as I said earlier, approached me at the end of my PhD saying they had thought I would do something different, that was a little bit too late, I guess, to tell me. But there were other moments where indirectly they had an impact. I remember I was working on my master thesis in quantum chaos, and I came home to my mother, and she said,
"Could you maybe give a broad understanding of what is quantum chaos? What are the questions you ask?"
The question is, there is two theoretical physics fields that emerged in the 20th century. One is chaos theory, that deals with an unpredictable chaotic behavior and how to model it mathematically, how to study and analyze chaotic behavior and ergodicity and lots of phenomena of that type. And the other one is quantum mechanics, a theory that emerged to model microscopic, typically phenomena that happen on a microscopic level. And both of these theories emerged independently in the 20th century. And one of the challenges is how chaotic behavior emerges in quantum mechanical systems. And so at the time I was studying this in my master's thesis, and I came home to visit my parents, and then my mother said, "So how are you doing?" "Fine." And she said, "And what is your master thesis about?" And I said, "Mom, do you really want to know?" My parents are educated, but they're both lawyers, so they have no math or science background, right? And then my mother said, "Well, why don't you give it a try?" And so I said, "Well, so right now I'm computing the energy levels of this hypothetical quantum mechanical system." And then I stopped, and then there was dead silence in the room. And then my mother said, "Well, as long as you enjoy it." And then I realized something struck me at that moment. I realized I do enjoy it, but there is more. I don't want to just do things that I enjoy, but that the layman does not understand. I want, and that also seemingly have very little impact on everyday life, on the humans around me. My mother said, "So what is this good for that you're doing?" And honestly, I couldn't really explain to her how that helps humanity. Obviously, it gives us a better understanding of the world, but an understanding that has, at least to a large extent, very little impact on our everyday life. And then I realized I want to do math, I want to do things that are mathematical and sophisticated, but I also want to do things that the everyday layman can understand and can resonate with, and can see what this is good for, how it kind of helps humanity.
I think it's very interesting that you mentioned that, because I believe it's a great challenge for everyone who studies more theoretical fields like mathematics or possibly physics, where on the one hand you want to use sophisticated tools and you want to understand the complexity of mathematics and physics, but at the same time you want it to have an impact. So I think it's a challenge for everyone to find the right balance for themselves, like how applied do I want my work to be to have an impact, and how theoretical I want it to be sophisticated and to be and to bring about progress. So that was a deciding moment when you were writing your master's thesis, and then you started a PhD. First, maybe tell me, why did you decide to pursue, to take the next step in the path of academia, and also tell us about your first PhD experiences.
So my first PhD experience was actually in the neurosciences. So after doing a master's in theoretical physics, I wanted to go into neural networks. That was actually my interest, right? I thought neural networks were exciting. I read a book from my colleague Helge Ritter about neural networks, and that inspired me a lot. And I thought, I want to do a PhD in neural networks, right? So I got in touch with a lot of researchers in the field, people including the famous Geoffrey Hinton, contacted all of them asking about whether they had PhD positions in this field of neural networks. And at the time, it was the AI winter. At the time, neural networks were out. They were developed in computer science, but they were found to not work super well. And so I got a number of professors telling me, "Young man, you seem quite talented. Why do you want to go into a dead field? Why don't you do something that has more of a future," right? And so I was a bit disappointed. And I still clung to this idea of neural networks. And so I started a PhD in the field of theoretical biology, where neural networks were important and are to date important, but for modeling the human brain, for understanding the human brain. And that was quite a fascinating field, how to model in particular the visual pathway in mammals and humans with mathematical models. And this is what I then set out to do in my first PhD. I always say first PhD because I never finished it. And admittedly, this may have been one of, at the time, something that I felt like a failure. Yeah. And And I've seen people, students that approach me similarly. They are in a position, they are not happy with what they're doing. They started something and they feel it's not the right thing, but they're reluctant to just let it go and start something fresh. Right?
Can I maybe ask how much time did you spend there before you realized that it might not be going anywhere?
I must say I spent a year there, and I must say this year in retrospect was a wonderful year. Even then I enjoyed it. It was Berlin, there was lots of culture, but also the research lab was a wonderful lab that my PhD advisor Andreas Hertz set up. He's the creator of the Bernstein Center for Neurosciences in Germany. A very talented, very nice, very smart advisor. And I was quite happy there, except the project I was on, I spent a year on this project and it wouldn't advance. And after a year, I felt I was, standing still. I felt like I wasn't making much progress and I couldn't see the end, let's say the light at the end of the tunnel, as they say. Right, and then I felt this is not going forward, and then I decided to drop things, and instead then I went into computer vision, into yet another discipline. So from physics over neurosciences and biology into computer science. And at the time, I was afraid I had just wasted a full year of my life. But in retrospect, time is never wasted. And the memories I still have of that period in Berlin are quite good. And also my relationship to Andreas Hertz, my then advisor, is still good. He was very unhappy when I left. He spent a whole day trying to convince me to stay on board, saying you should not leave, this is not good, you have to finish things that you started, which in general is a good recommendation. But still, I dropped everything. I was decided. I left. I went into computer vision, did a PhD there, and not even 3 years later, I was a lifetime professor, right? And incidentally, the very first person who congratulated me on my professorship, I was 34 when I got the offer, was Andreas Hertz. He contacted me saying, Daniel, I saw that you got the faculty position in Bonn. That's amazing. Congratulations. And then this showed quite some grandeur, I found. He said, it shows that you did the right decision leaving me at the time. Right? And then I said, no, Andreas, I'm sure I could have become something as well if I had stayed with you. And he said, yes, but you would never have become a professor at this speed. This is unusual.
Yeah, I think that's a wonderful story of how what at first might feel like a failure, might feel like you've wasted a year, later turns out to be a very, maybe a stroke of luck, and maybe also...
And it wasn't a failure, indeed. In retrospect, I know so much about how the human brain works, right? And we as computer scientists always try to reproduce the capacities of the human brain, and then obviously it helps to have a very good understanding of the mathematics that govern neurons, etc.
Yeah, so you mentioned your PhD, and then after your PhD, I know you did research at UCLA as a postdoc, but also in industry at Siemens in New Jersey. Mm-hmm. Could you maybe talk a bit about your experiences there, and maybe also the difference you perceive between doing research in academia versus industry?
So a lot of these career decisions, in retrospect, often they look like they're carefully planned and designed, what is the best place to go. I did plan, but then a lot of things happened very much randomly. And sometimes I think life is a little bit driven by random incidents. And here as well, for example, I was actually considering many labs for postdoc, and I had planned to go to France as a postdoc, because I had been to the US for 2 years already, one in high school as an exchange student, and later one in college as a Fulbright scholar. And so I felt I speak English fluently. I've seen the US, different locations, and I wanted to learn more French. I had learned French during my civil service in France, so I spoke French as well, and had collaborations with researchers in France, and was planning to contact a professor, Olivier Faugeras, a famous computer vision researcher in southern France. I was actually working on the email to contact him, and I remember distinctly that I couldn't, I was a young PhD student, I didn't know how to address this famous professor, right? So I started, Dear Professor Faugeras, and then I thought, don't they usually say Dear Dr. Faugeras? So I changed. I said, Dear Dr. Faugeras, and then I said, well, I've met him. I shook his hand so I could be bold enough and say, Dear Olivier. And so I said, Dear Olivier. And then I thought, this is France. This is not the US. I should better. And so I was switching back and forth, and I couldn't really move forward on this email. And while I was writing the email, my email program, at the time it was still beeping. I switched that off. Now it wouldn't beep. But at the time it beeped, you have a new email. And so I said, let me move that to the side and first check what's the new email, right? And the email was from Stefano Soato at UCLA saying, Daniel, it was a pleasure to meet you at the last European conference, and I really enjoyed your research and your presentation. I'm offering you a postdoc position for 5 years. This is the salary. Would you be willing to come to UCLA? And I remember going back to this email I had started to Professor Faugeras, and I edited a little bit longer, and at some point I said, to hell with it. I never sent the email. I never sent it. I just accepted the UCLA offer and figured UCLA is just as good. Let's just go there, right? And I was happy there. It worked out well. And so often these career decisions have quite a random element. And I always tell my students as well, for me, life is much like a hike, like when you go hiking, right? You start on a path, but sometimes you take a detour. And these decisions, let's take this or that detour, they often come very quickly. In an instant, you think, okay, why not do this? Why not do that? And so to a large extent, my life feels a little bit like a leaf in the wind. And sometimes the wind blows you this way, and sometimes it blows you that way. And that's okay.
And does the French professor know you were going to contact him? Did you ever tell him?
I don't think I ever told him. I've met him many times afterwards, and we're good friends, but I don't remember. I may never have told him.
So maybe if he watches this podcast, he'll find out this way.
Good point, yes.
And then you were also at Siemens in New Jersey, right? Was that an important part for you?
Siemens was similar. I was sitting at UCLA doing research, and then my email program, a new email from someone at Siemens in Princeton saying, Daniel, we would like to hire you. If you're interested in joining Siemens Princeton, we would be happy to invite you for interviews. And this is an unusual case. It was really a headhunting kind of case. So I never applied to Siemens, but I was in a situation where I had spent almost 2 years as a postdoc, and I felt it's time to move on. It's this restlessness that I mentioned. Whenever I spend a few years in a place, I felt I've much like a sponge absorbed all the kind of, or lots of the knowledge in the environment. And at UCLA, there was a lot of expertise in computer science, in mathematics, in statistics. I worked with many researchers. But after 2 years, I had a feeling I know a lot of it. I know how people tick, how they work, etc. And I had the feeling it's time to move on, but I didn't know what. And then in turn, German academia expects you to spend like 5 or 6 years at the time on postdoc before they give you a lifetime professorship, right? And whereas in the US, typically people start a professorship, assistant professorship in a tenure track system right after the PhD, or maybe 1 or 2 years after. And one of my colleagues, Gerard Medioni at USC in Los Angeles, over lunch, he said, Daniel, don't do 2 postdocs. That does not look good on your CV. Top talents get a professor position in the US right after the PhD. If you do a postdoc, then that's okay. But if you do 2 postdocs, it doesn't look good. It looks like you are not getting a faculty position. And I said, well, the German system is different. And so in that kind of dire situation, he said, don't do another postdoc. The German system expected me to do years of postdoc, right? I didn't really know what was a good option. And then this offer from Siemens came by, so I thought, why not? And so I went, I interviewed, and this was probably for them, one of my colleagues later told me, one of the strangest interviews he ever had, because they were expecting to interview me, and he said, It was actually the opposite. I spent most of the day interviewing them. I asked so many questions about their work, how they do that, why I do it this way, why not that way. And he was sitting there in the interviews thinking, this is weird. I should be asking the questions, not you, right? But why did I do that? For me, and this is my recommendation to researchers always, when you pick the place to go to, make sure that you have top talents in that field, people you work with. Who are the people you work with? Are they good? How good are they really? And the only way to find out is by asking, right? And so I interviewed everyone there, and I realized this is an amazing place. They have super talented people. And so I said, I'm happy to join you.
And how did it compare to UCLA? Especially the difference between industry research and purely academic research.
So that depends on where you go, but for me it wasn't all that different. And this was a big surprise to me. I was expecting company means you work on specific products, but in my case this was not so. I remember in the first week of work at Siemens, you have in the US what they call the goal setting meeting, where you meet with your supervisor, manager, and you discuss what are the goals for the next year, right? And he called me into his office for the goal setting meeting, so I was a little bit afraid, okay, what's going to happen now, right? I come to his office and he says, you don't even need to sit down, you only have one single goal. So I said, okay, and what is that? He said, publications. And then I said, okay, publications on any specific topic? And I was very surprised. He said, no, doesn't matter, whatever you like. So industry, and this is true for a lot of the big corporations, they have funding to hire top talents and basically let them do what is called blue skies research, to let them do whatever they want. And I was one such case, and so then I started working on all sorts of things that, Siemens in Princeton is mostly doing medical imaging. Some of my papers are indeed on medical imaging, but this was my personal choice because it felt awkward doing something completely different in an environment of medical imaging. But I've done papers that had nothing to do with medical imaging, and this was one of my most productive research phases because I didn't have any other obligations except publication. So this is what I did, and I was happy there. And I think that also propelled my career, and that was part of why I got the faculty position fairly early on, not even 3 years after graduating.
Mm-hmm. Wow, that sounds wonderful. So now we've talked about where you did your research. Let's maybe talk a bit more about the topics of your research and what your research is on. So you already mentioned you do computer vision, and you do many things within computer vision. One big aspect of your research is 3D reconstruction. Can you maybe tell us a bit about your approach to that? What are the challenges? How does it work? Why is it difficult? And what have you achieved in the field?
So yes, 3D reconstruction, computer vision is a broad field, and computer vision for me is one of the most central aspects in artificial intelligence. This is part of what's called AI. AI is now all over the place. Everyone's talking about it. It's all in the media. But if you talk to people on the street, you realize people have no clear idea what artificial intelligence really is. And in fact, it is a very vague thing. It is a broad field that, ranges from just chess-playing computers all the way to any kind of data analysis and data processing. In principle, what was just called data processing in the past is now called artificial intelligence, and every medium-sized and big company will claim it has an AI, and it just means they process data, right? So there is this spectrum. And I think originally AI started with chess-playing computers. This was at least one of the core kind of driving things that you could see. We can teach a machine to play chess. And as I said, in my childhood, I realized that this is a solvable problem. And I'm not surprised now. It took years from my childhood until I think in '96, the world leader, the world chess champion was beat by a computer. And since then, it's kind of a solved problem. at least in terms of beating the human. Now you can have computers play against each other and continue the game, but at least beating humans in that discipline is solved. But for me, this is not the core of AI. And the reason is that chess is a game that is limited to 8x8 places, right? So it's a very constrained setting, and each figure can only move in a very limited number of ways. And so you can actually count the different numbers of possible configurations. And at any given time, typically a player has in the order of 10 possible moves, or maybe 20, right? Obviously, if you count 10 moves on my side, 10 moves on your side, 10 moves on my side, then, you have 10 times 10 times 10, so things, exponentially grow, but it's still feasible to compute brute force, say 5 or 6 or whatever iterations into the future. What happens if I move this or that? What is the worst case setting? And to see, how can I optimize that? And this is what you can do. And so you can actually more or less brute force compute what is the best move. And that is kind of, in that sense, solvable. And for me, the story really begins when things cannot be put into simple rules. And it also really begins when it comes to the things that the human brain is designed for. Because let's be honest, the human brain was never made to play chess. Right? And so we as humans, by evolution, are not good at playing chess. The whole brain is not set up to do this. So it's actually quite surprising that humans can play chess, right? And not surprising that the machine can do it. Whereas what the human brain was designed for is understanding and predicting the world around us. And this is a very sharp and harsh evolution criterion, right? Survival criterion. If I can predict better what the tiger in front of me is going to do next, I will just live longer, right? And so understanding our world around us from our senses, seeing there is a tiger, there is a crocodile, and predicting their movements, their behaviors, learning from experience, predicting the future, this is what humans are amazingly good at.
So it's
a survival skill.
So it's these two things. One is you look around and you see the world and you know the objects, this is a shelf and this is a chair. And then the second step is to predict what is going to happen.
Yeah.
What is going to happen next? How do the objects work? How do the physics work? And
exactly.
What will be the future of this?
Exactly. And in fact, computer vision for decades has focused on, seeing objects in images. This is one of the big challenges there, saying there's an airplane, there's a bookshelf, there's a car, there's a bicycle, etc. That's all nice, but I would say it's to a large extent also solved. We now have learning-based algorithms that can outperform humans even in that challenge. But for me, that is actually one of the biggest breakthroughs of neural networks, because they were able, this was in 2012, a paper by Alex Krzyzewski and collaborators who showed that you can recognize objects in images with suitably trained deep networks. And for me, this is the real breakthrough of AI. It's not playing chess. Beating humans in chess is easy. But beating humans in the challenges that the human brain was designed to solve, recognizing things in our world from images, either through the eyes or in our case through cameras, this is what the human was designed for by evolution. And beating the human on that challenge, this is for me the real breakthrough of AI.
So maybe AlexNet was the breakthrough when it comes to teaching machines how to understand the world around them, a very first step.
Yes. So obviously there's a lot of pioneers in neural networks. The things go back to even Sigmund Freud thinking about how neurons interact and how one could model that. And in the 80s, there were the first, neural networks in computer science being deployed. The deeper networks, Jan LeCun and others, but also Geoff Hinton and many others worked on this and developed the foundations for this. But one of the biggest breakthroughs in computer vision was definitely the AlexNet in 2012. And not surprisingly, that paper has been cited more than 100,000 times by now. And so this is one of the most influential papers I have ever seen in my life.
Wow. So recognizing objects was one of the first steps towards understanding the environment, and then another is maybe 3D reconstruction using cameras to understand the 3D structure of the world.
Yeah, so for me, for some reason, recognizing objects in images has never fascinated me so much. There is a car, yes, the system says there is a car. For me, 3D reconstruction has always been more fascinating, and so I've focused more on that topic over many years. And it is, about the world that we live in is a 3D world, but when we see it with our eyes, all we see are 2D projections of this world. And how we can recover a 3D understanding of the world, of the objects in this world, this is a big challenge. It's happening in the brain somehow. We don't really understand at detailed level how the human brain does things, but how to reproduce this 3D reconstruction in a machine is something that I find fascinating. And it's, to put it in layman terms, what we expect from our computer is that it recovers a 3D model of the world, much like you would as a kid when sculpting something from little Lego blocks, right? And as you remember, we all played Lego as children, and I have 3 kids of my own now, and so I spend a fair amount of my time playing Legos. And one thing that always amazes me, and I don't think my children are quite aware of that, is if you have a grid, you can place a little Lego block or you cannot place one, right? So in principle, for every grid position, you only have 2 choices. Either you place a Lego block or you don't. That's simple, but if you consider all these grid positions at the same time, then you have exponentially many possible configurations of Lego block and not Lego block, right? So even for just 2 grid positions, there's 4 possible configurations: Lego, Lego, no Lego, Lego, etc., right? And with every additional grid position, the number of possible configurations doubles, to the extent that if you have a grid of, say, 512 by 512 by 512 elements and you want to fill them with Lego blocks, then you have already 10 to the 40 million possible configurations. Right? And then if you devise a super smart algorithm that can evaluate each configuration to check, does it match my images? Or how well does it match my images? And to figure out which configuration matches best the images. You cannot try all configurations. You don't have enough time, right? Even if your software runs in a nanosecond, let's say, that's super fast, right? Still, 10 to the 40 million, you would wait more than the age of the universe until this code is finished evaluating all configurations. So you realize this strategy of what we call in computer science a complete search, it doesn't work. And so we live in this what's called the big data age. Big data is a topic that's also been in the news. Everyone talks about big data. For me, this is puzzling because for us in computer vision, it's always been big data from my day one. When I started in the 90s, it was big data, and there's no difference now. It's still big, right? And it's not. And one aspect of big data is that the solution spaces get very big. 10 to the 40 million conceivable solutions. Find the best one. Well, good luck, right? And so you got to tackle this problem in a smart way. And this is, in fact, one of the biggest, I think, breakthroughs from a theoretical point of view that we achieved in our work, is we were able to show that our machine can indeed compute the best solution among all of these 10 to the 40 million configurations by so-called convex optimization methods. The idea here, this is gets a little bit technical, but the idea you have to imagine when you search for the best solution, the machine searching for the best solution, the best 3D reconstruction, is very much like you hiking in a landscape and being asked to go to the lowest point of the landscape.
Which would correspond to the most accurate approximation.
Exactly. So you can imagine the landscape is all conceivable reconstructions, right? They are spread out in a landscape. And the quality of each reconstruction is, let's say, corresponds to the altitude of that point, right? And then I would say in that landscape, the best quality reconstruction corresponds to the point of lowest altitude. And so the optimization algorithm that tries to find the best reconstruction is much like you trying to find the lowest point in a landscape. And now it's obvious if that landscape is convex, like so, then it's easy. You just roll down the hill until it doesn't go down further, and then you are provably at the lowest point. But if the landscape is not convex, like in the Alps, and you have lots of little valleys, then, to find the lowest point, you might have to wander all over the place. And that, if we go hiking in the Alps, we know could take forever, right? And we don't have time. We don't have forever, right? So we need to do things efficiently. And what we showed is you can start with a non-convex landscape and reformulate the same problem in a way that it's equivalent to a convex one that can be solved efficiently so that I can end up getting the optimal solution fast.
So you use convex optimization, and that basically convex optimization means you have a local minimum, so you look around and you're at the lowest point that you can see, and that automatically tells you this is the lowest point there is. Mm-hmm. So you reformulate this complex problem in a very intelligent way that enables you to find a solution efficiently.
Exactly. And I should say, I'm in computer science, but also in mathematics. And on that facet of my work, it goes very deep into mathematics, because to explain how you can convexify an originally non-convex problem requires quite an amount of sophisticated mathematics. And this is where I'm happy about my own math background. But I should say we also collaborate with a lot of mathematicians all over the globe. And in that sense, the research in my field is extremely interdisciplinary. And this is something people don't realize, students often don't realize. They start on a specific path, say physics, and they assume that means they will become a physicist. No, you don't have to. There are so many ways, as I mentioned, it's like hiking. There are so many alternative tours that you can do. We recruit people from mathematics. We have a lot of PhD students who are mathematicians by background, from computer science, from electrical engineering, from physics, from statistics, from lots of different disciplines. They all come together and collaborate. And for me, this is one of the most enriching things about my work, is working with people from different backgrounds, because you learn so much from others.
And then not only in this project did you work with scientists with different backgrounds, but you also decided to turn it into a product or a startup idea.
Yes.
Do you want to tell us about that story?
So 3D reconstruction has many application areas, and one thing we developed, this was together with my then postdoc Jürgen Sturm. This is Jürgen.
Hello, Jürgen.
Pointing in the camera a little bit. So this is Jürgen, and together with Jürgen, we developed algorithms that can scan humans in 3D in basically a few seconds. Right?
Using only normal cameras.
Off-the-shelf cameras, just a single camera, in fact, that just pans around, or you can turn on the chair in front of a static camera at home and just rotate around once, and instantly you get a 3D colored 3D model of yourself. And you can see, this is Jürgen. Here he is again with a tie. In fact, that's together with his wife Julia, and this is how they placed themselves on, I think this way, on their, when they got married, on the cake, they put themselves like this, like real copies of themselves. And you can see the figures are very detailed. I have figures of many of my former PhD students that are very detailed. You can even read what's written on the T-shirts. So these 3D scans are essentially, photographic copies of the 3D world, 3D photography, if you will. And so rather than, we figured there must be a huge market for this. And this is why Jürgen and I created a startup together, one of my first startups, And we figured we can commercialize this to offer people the possibility to scan themselves in 3D at home. For the parents or the grandparents, rather than having a photo album that is on the shelf, you can have a real kind of 3D tangible copy of your children and grandchildren. And so our grandparents are quite happy. They all have copies of our kids at home on their shelves.
So you developed the technology and then you thought, oh, wow, that's so fascinating. There has to be a market for this. We have to turn this into a company.
So we did, and there's different scanners. Some can do full body scans. This is me in full body 3D. This is the current TUM president in 3D. This is Markus Söder, our prime minister, in 3D. So we can scan lots of people in 3D. Here's another student of mine, and you can see they're sufficiently detailed that you can really recognize the people from the 3D scans. And we figured, yes, let's do this. We created a startup, but it was, in retrospect, a startup where we never went far. We never actually brought in investors or funding or business angels, right? We thought about it, but we figured it's already creating revenues. Why should we get investors on board? But the issue was that the revenues were never sufficient to hire a full-time employee, always a little bit not enough to really hire a full-time person. And it meant that even, writing the invoices, I had to do that myself, right? And this becomes quite tedious, and communicating with hundreds of customers. And at some point we didn't continue this. And the reason is also that as researchers, we're kind of in the situation where we do entrepreneurial activities, but we're also expected by the public to publish what we do, to disclose how we solve these problems. And so we wrote a lot of papers where we detailed exactly how we solve this problem, and that obviously opens up the door for competitors to enter the market. And so there's by now lots of companies, competing companies that offer similar technologies. And so I think at this point, it's probably a little bit too late, but every now and then I keep revisiting. We still work on this in academia. We do research on this, but commercially we are not at this point pursuing this.
So what would you say were the lessons you learned from this early startup experience? What would you maybe do differently if you were to approach it again?
So what I would do differently, and what I learned, is Jürgen and I, we're both techies. So we understand exactly how the technology works. We can refine it, we can sophisticate it, we can make it better, we can make it the best in the world. And in many ways it was at the time the best in the world in terms of speed, robustness, accuracy, right? But we're not business people. And that requires a somewhat different mindset also to figure out. And this is, I think, the most crucial thing in a successful startup, is understanding who exactly is my customer. Who is my customer, and what does the customer want? And how much is that customer willing to pay for it? Because a lot of the technologies we develop, people are blown away. 3D reconstruction, we can reconstruct 3D people. We can even reconstruct actions from synchronized videos at levels of detail where you can do sports analysis and 3D television and things like that. People are often blown away. We can recover in real time from walking smartphones the whole 3D world around us, right? At a level of precision and accuracy where we showed with self-driving cars that you can drive for kilometers and have a drift of maybe a meter or so. Right?
What's drift?
Drift means you estimate the position of your car purely based on cameras. Where am I in the 3D world over time? You create a 3D map of the world and you can localize yourself in the map. But if you estimate the camera from frame to frame over hundreds and thousands of frames, minutes of video, you accumulate errors in your position estimates, and these errors aggregate to what's called a drift. And so in the end, you are not exactly where you think you are, but you're off by, say, a meter or so. And our algorithms had the smallest drift worldwide in terms of real-time capable camera tracking. We've developed some of the most powerful algorithms, and for all of these, you can create startups and commercialize this, but what is important is not so much how great is the technology, but much more is who is the customer and what is really his pain point, his or her pain point, what is really the need of the customer. And this idea that saying this technology is so great, someone is going to buy it, this is not sufficient for a startup. You have to understand who is that someone and what exactly is he interested in. Is it the map, the 3D map? Is it the location? Is it something else? And very often when you actually interact with customers, you start realizing what the customer really needs is something different. And then you have to think about, should I not develop what the customer wants? And this market fit, as they call it, product market fit, this is something that is crucial and that requires a particular skill set. Someone with a business side, maybe someone with an expertise from that domain, who can understand what is the main pain points of customers.
So probably that's a lesson to be learned for like everyone who's in science and who does research, who's broadly interested in startups. Like, it's not enough to have cool research, but you also need to know your customer and need to find product market fit and make a good business case. So maybe if you love your research and think everyone has to love this is so great, maybe take a step back and think about who's my customer, what do they want, what are they willing to pay for it, why are they willing to pay what they're willing to pay for it. So maybe don't just think about the research, but also think about the customer who you're selling to.
And from a kind of wider perspective, what's also important is the overall ecosystem. And this is something where I think in Munich we're fairly good, but not quite on par with what you see on the West Coast in the US. This ecosystem that includes techies that develop the cool technologies like us, right? But then also business people who have an understanding of a certain market, but also potentially investors who can bring in the funding to scale up activities quickly. Because often once you see that there is a potential, time is also critical. As I mentioned with 3D scanning, if you wait 2 or 3 years, then competitors are on the market and then things may be too late. So often we see that the most successful companies are not necessarily the ones who have the best technology, the best product, but the ones who were on the market first. And this is often speed is an issue, and speed comes sometimes with having investors that can support you and bringing everything together. And when you give a talk on the West Coast, typically you present new technologies. Right after the talk, investors will come up to you and say, I will put 2 million into a startup if you do a startup on this, if you support us. This, to date, doesn't happen as much in Munich yet. We are working on this, and I am investing time to support the structures that help to build up these kinds of ecosystems that we need to bring technologies into the market quickly. And in my view, startups are one of the best ways to bring technologies into the markets quickly, because startups can focus 100% on this new technology. Often big companies have their own agendas. We also work a lot with big companies to commercialize technologies, but sometimes the time processes are a little bit slower than, say, in a startup.
So this is something where Europe, or Munich specifically, still can learn from the US, how we take investors and take business people and enable them together with researchers to quickly turn research into products, into tangible companies.
Yes. So I think definitely Munich, Germany-wide, is one of the leading places in startups, and actually the leading place. If you look at Crunchbase 500, Munich is the number one. In particular, TU Munich is very strong. It's called the Entrepreneurial University. So there's a lot of support at TU Munich to foster these startups. And we've received support, and I want to give back. And so this is why also I'm serving as advisor to a lot of startups and supporting young people on their path to hopefully a successful company.
Are there any other hubs in Europe that you find interesting? And maybe also, do you think there's some convergence? Do you think we're catching up maybe? Or is it the other way around, that the difference is getting bigger and bigger?
So I think we are catching up. One measure here is how much startup funding can a startup aggregate in different countries. And whereas in the US and in China, you can get many millions. Even, one of my friends, Raquel Urtasun, she recently created a startup, Wabi, and she got seed funding of 100 million. So this is quite a size. This is Canada, I should say. It was, I think, the biggest seed funding in Canada ever. So this shows you how much seed capital you can get in the US. In Germany, I think you would never be able to raise 100 million seed funding, but we're getting better, right? And for example, the startup we created after the startup with Jürgen, we did Artisense. And Artisense was a startup where we raised more than 4 million seed funding. And this was, at least for German standards, quite a large seed round that we raised. And we see a number of companies that are quite successful. Companies like Celonis that are now multi-billion-dollar companies started in Germany. So we can do it, and Munich is a good hub to do it. There's other good places. Berlin is obviously also a top place for startups. There is some competition among the different locations in Germany, but also a lot of interaction and collaboration. And in the end, I think Germany is advancing, and I see that things are developing in a positive way.
So you talked about Germany, about Munich being very successful, and also Berlin. Are there any other European startup hubs that you think are interesting?
So I definitely see that all the European countries are putting a lot of effort into improving the startup world, also in the UK, also in France, everywhere. In the Scandinavian countries, I see there's a lot of focus on this aspect. And I think things are advancing. But definitely one of the big differences, at least when I compare Germany to the US or China, these are, I think, our main competitors in the startup world. In China, you can also raise billions easily for startups. And I see that happening frequently to competitors in our field. One of the aspects in the German startup world is, to date, people are a little bit more, investors are often more focused on revenues. So they want to see revenues on a fairly short time scale. And sometimes if you develop the future technology, you may not have revenues on a short time scale. I think companies like Uber or Lyft, they don't really create significant revenues, and investors pour a lot of money in to sustain them, right? But in Germany, this is more difficult to get investment if you don't create revenues. And as a startup, sometimes you always have to focus. You cannot do everything, right? Either you develop the cool futuristic technology, or you create revenues on a short time scale, which means you interact with customers, you ask each customer what he or she wants, and then you develop exactly that customized product that doesn't necessarily scale, but it gives you revenues. And while you work on projects for customers and fulfill their requests, you cannot in the same time develop the scalable product, right? Mm. And so there is this trade-off. And then to some extent, the investors favor short-term revenues over scalability. Whereas in the US, they give you a lot of funding and say, just develop the cool product. If you don't create revenues for a few years, that's okay. So there is a little bit of a different, I see a different mindset among investors. And the German investors often favor smaller tickets. They give you 100,000 euro, 200,000. And, there's not so much you can do with 100,000. Sometimes it takes more. And so Artisense, for example, was a company that we created.
When did you start the company?
The company was started, I think, around 2017. Things really got going with a co-founder or two co-founders of mine. And so that went quite well. We got a lot of investment, and that allowed us to scale up quickly and hire talents and develop innovative technologies for autonomous systems and for self-driving cars.
So let's talk a bit about Artisense. So first, maybe how did it start? What sparked the idea to start the company? What was the technology behind it, and who and what did you want to achieve with that technology? What did you want to use it for?
So the technology that sparked everything was technology we developed here at TUM that allows you to track cameras at super high precision, robustly in real time. So you can really take a smartphone or a camera like that, walk around the hallway, go into the subway, back out, and you can track yourself at super high precision and in real time create a point cloud reconstruction of the world around you. And we showed in research that this point cloud and your location is sufficient to do things like obstacle avoidance and path planning, for example, for autonomous drones. And we showed that just using the cameras on the drone, we can navigate autonomously. We can have a machine fly through a 3D world. It creates a 3D model of its world and its own location. And you can imagine for these applications, real time is crucial. For autonomous systems, but also for augmented reality, you need to know where is my camera in real time. And you need to have robustness and you need to have precision of your location. And our algorithms were the most precise and robust among all real-time capable algorithms. And these were some of my most cited publications ever because they were so popular worldwide. And then we figured there must be a commercial value. And then remember we were sitting at exactly this table here, and it was a friend of mine, Andrei Kulikov. He reached out, he said, Daniel, how about we create a startup?
Is he also a researcher, or what is his background?
He came from autonomous driving. He came from the automotive industry, and he had 12 years of background in automotive, and he brought the domain knowledge that I mentioned you need to understand what is automotive interested in, what do they need, what is their pain points, that we deliver the product that they actually need.
So you had the founding team of 2 people?
2 people, and then we brought in a third person. This was Till Kestner. Till was the guy who basically built up LinkedIn in the whole German-speaking world, in Germany, Austria, Switzerland. And so Till had huge expertise in company building, team building, etc. He's an extremely charismatic person, and I learned a lot from him about communications, about team building, and he could be extremely inspirational, etc. And so I think we formed a great founding team, and we built up, and the 3 of us kind of raised the over 4 million seed funding, and then started building this company.
And then, so after you'd raised the funding, what were the next steps? So did you hire many people? Or?
The next steps is hiring. And on one hand, you want to hire a number of people. You want to have the manpower to solve problems, but you need to hire the right people. And this, I think, is crucial. And this is sometimes the competitive advantage that startups can have, that they know exactly who are the right people, who are the top talents, and can make sure that they hire. Because I found a top talent is often better than 10 mediocre talents, right? And so there is no point in hiring 10 people if they are mediocre. It's much better to hire a single person if they are really top talent. And Artisense hired a large number of really talented people that developed amazing technology.
Is that maybe part of your role as the scientist within the founding team to recognize who are the talented people, who's best at what they do, and then maybe also the ability to attract top talent?
I've asked myself that, and I think you hit a very important point. I think that is my main contribution. I do a lot of things in startups and support with my expertise, with my background, but indeed the most important point is talent scouting. Because as a professor, I am surrounded by talents, especially at a large university like TU Munich. We have one of the largest, if not the largest, computer science department in the country, a very large math department as well. And both departments are among the strongest departments nationwide. And so we have super talented students, and I see them on a daily basis. And this is somehow my job as a professor, is to evaluate students and to assess their potential and their talent. And I think this is a skill that I've developed very, very early on. I remember when I started college in Heidelberg in physics, the largest physics department in the country, there were like 400 students in our semester. And I very quickly saw who were the top talents in my field. I think I've always had an eye for talents from even in high school. I always admired smart people, and I look up to smart people. And I should say I've had PhD students like this guy, for example, Yevgeny, who were much smarter than me. And so I love working with talents, and I think I have an eye for talents.
So that's one way how you were able to use your experience from your day job as an academic to help the startups. I've spoken to a few people who were actually your students at TU Munich, and they all admired you also as a teacher. Mm-hmm. So maybe would you like to talk about what teaching means to you, and maybe did the experience you had from teaching benefit you as a startup co-founder in any way, or do you think there's no connection there?
I think there is a connection. So I definitely love teaching. And I should say I'm very happy in academia. I had many, many offers. And if you look at our field of machine learning, AI, you see a lot of professors, even from top universities, established full professors, get recruited away by industry. This is a trend I've seen increasingly over the last years because, let's be honest, the salaries in industry are unrivaled. You cannot match them with university salaries. This is true. TU Munich pays very competitive salaries in Germany, definitely also Europe-wide. I think the salaries are really top at TU Munich. So I think we're doing a good job here to retain the top talents in our field. But obviously we cannot, Google pays salaries, annual salaries in the range of 7 million to people in my stature, right? So, obviously TU Munich does not pay a 7 million annual salary. I think that's no secret if I disclose that here. But it pays handsome salaries, but this is one of the reasons why academics get drawn away into industry. I had lots of offers from many companies like Google or other, but I always said, no, I'm happy here. Because for me, it's not about money. For me, it's about working with talented people, and it's about recruiting talents. And I think this is my main job, to target, identify talents and support them. And this is what I enjoy most, is basically spotting talents and also inspiring them and somehow motivating them on their path to success and seeing them develop their skills and their talents and seeing them kind of unfold their potential. And this is for me the most rewarding thing in my work.
I imagine you're probably also in a very in the optimal position to do that as a university teacher who also has close contacts with startups. That way you get to see much talent, you get to teach them, work with them, and then maybe show them what's out there, what they can do with what they know and with their skills.
Yes, exactly. And so this is what I love to do. And if there's one measure of success for me, researchers measure their success in many ways. In academia, you can measure it in how much third-party funding, how many millions of funding they brought in. You can measure it in how many master and PhD students they graduated, or you can measure it in how many papers they wrote, how many citations to their work, what an H-index. There's lots of metrics of performance, but for me, I realized the most important metric to me personally is to see how successful are my former students and postdocs, right? And to see that there's already more than 10 of my former postdocs who are now professors of their own, or to see what some of my PhD students achieved and managed to do. This is the most rewarding thing for me.
Yeah, that sounds like a wonderful achievement, seeing what your former students are up to and what they can achieve in the world. So you talk about the success of your former students. Let's maybe one more time
go back to Artisense, what is Artisense doing now? What's the current status? Are you still involved with them?
I'm still involved I still have kind of in particular an advisory role in Artisense, in the science kind of development of Artisense, but we actually sold Artisense. So this is typical in the lifetime of companies that sometimes you sell them.
When did you sell them?
We sold it essentially last fall, so almost a year ago we sold Artisense. The reason being that at some point there is a lot of responsibility and burden for me as a founder in particular to make sure that the employees get their salaries, and the company develops and is still developing and developed at the time very amazing technologies, but the revenues were not quite on par to match the salary expense, because we had a large team of 30, 35, at some point even up to 40 employees, right? And so that creates a large what's called burn rate. So we had a monthly burn rate of, I think, in the range of 400,000 euro, right, a month, right? And so you have to bring in that funding. So we raised more and more funding from investors, but at some point it felt like a lot of responsibility, and we had built up a successful company with top talents developing top technology, and that felt like a good time to sell it. So that someone else is now financially in charge and to run the show.
So the reasons for the exit were you still were burning through a lot of money, and it was a large responsibility to run that big company. And maybe what you want to focus on is like the research, bringing together intelligent people. So you thought it was a good point in time. Like, it's doing well, they're doing great research, but they need to be bigger, and there's a lot of money involved. So you decided to hand it off and sell the company.
So this actually works quite well, because now I no longer have the financial responsibility. It was acquired by a Japanese company named Kudan, who is publicly listed in the stock market. And so for them, it's much easier to cover the burn. And I'm still involved supporting the company, the Kudan Group, to develop cool technologies and to thrive.
That's wonderful. So I know you can't disclose the exact amount, but maybe can you say, was it a lucrative use of your time working on Artisense?
So I'm not allowed to disclose details, but I can say yes. In fact, I don't regret not going to work for the big corporations, because once you create a startup, that can become much more lucrative. And also, if I do, and this is still kind of for me a driving ambition, I like tech transfer, but I much more focus on startups than working for big corporations, because in startups, not only can it be more lucrative if things work out, like in our case, but also you can really do your own thing. If it's your company, you can decide what to do. In big corporations, they give you a lot of freedom, but ultimately you will always have someone above you in the hierarchy. And I've seen it with many companies. On very short notice, things can change. Priorities can shift, and all of a sudden, the company that said we focus on publications, maybe a year later says we should focus more on products, and we should get rid of that line of products, but instead focus on this. And these are decisions that sometimes trickle down, top down, that you have no control over. And in a startup, obviously the customer tells you what you need to do. As I mentioned, you have to find this product market fit, but still you have freedom. You can drive the story the way you want it to go. And I think this is something that I've always liked a lot in life. If I can influence things fundamentally and decide how to do things and in which direction to move.
Yeah, that's definitely something visible throughout your career, different points in time. So I think that's also great inspiration for like young people who are considering like, should I do my own thing? Should I do science and maybe a startup? Or should I take the money and go to a big company? So you're saying, one, you have much more freedom to decide what you want to do, where you want to go, what direction you want to head. And at the same time, if you do a good job, it can be just as, if not even more lucrative than going into industry. So maybe startups are or not maybe, like clearly you show how cool and fascinating startups can be.
So in our field, you have many possible ways. You can stay in academia. There's a lot of opportunities coming up now because AI is becoming so popular. There's so many professorships opening up, looking for talents, right? But you can also do industry, and then you can go to big corporations. A lot of my PhD students join Apple, Meta, Google, Microsoft, BMW, Siemens, many of the big companies. But you can also do startups. And I always say all these paths are valid, all these paths are good, and you can really not do anything wrong. It's important. As I said, life is like a hike, and you can go different tours and detours. And what's important is once you go a certain path, it's typically not a wrong way. There's many ways that lead to Rome, as they say, right? And this is the same for career decisions. And so you can join a big corporation. This can be nice. I joined Siemens as a big corporation, and I was happy there for a time. But you can also create a startup. And this, incidentally, is something that I strongly advocate, because in Germany, a lot of the young people don't have that mindset. They are rather risk averse. Germans tend to be somewhat risk averse. Germans notoriously still put their money into a bank account rather than into the stock market, arguing, well, the stock market could go down. Yes, it could go down, but it could also go up. There is risks. And I think if there's one character trait that marks me, is that I've been open to taking risks. I'm happy taking risks, and I'm not afraid of putting money into the stock market, right? And I think life is about taking risks. Life is about exploring and going to your limits and beyond, right? And seeing what you can achieve, what you can do. And often startups are good when you're young, because they're often very time-consuming. You really have to dedicate your full time to it. And I always say, if it doesn't work out, you can always join Google and Microsoft afterwards, right? There's still time, right? And so I think the young age is when people are typically courageous and are more daring, and when often they don't have yet a family. And because with big corporations, you have a safe salary. And I see that now, having a family with 3 kids, safety is valuable if you have children. But if you're young and maybe you don't have a family yet, then it's a good time to take risks and to try something and to try. And I've seen so many young talents in my field. They create a startup and sell it for millions a year or 2 down the line, right? And then they could retire, right? One of my good friends, Michael Bronstein, and his brother Alex Bronstein, they are kind of serial entrepreneurs and have been an inspiration to me as well. They've created so many startups over the years and sold them for millions often, right? And I remember when I met Michael at the airport going to some conference, and I said, Michael, you sold your last startup for so many millions. Why do you still work? And then he said something that marked me. He said, well, Daniel, you can't do nothing in life. You have to do something, right? And then I realized that I don't actually work for money. I work because I want to do interesting things, right? And there is, in our field of AI, there is abundant funding and money. And this is also my message to young people. Often when they graduate, they seem the need to get money. No, you will soon have more money than you can ever spend, right? And then the question is more, what do you want to do with your life?
I mean, yeah, I fully agree with that. Maybe that's something very specific to the probably very privileged field, currently very privileged field of machine learning. But in general, I think like 2 important takeaways, not only for people who are machine learning, but also in many other disciplines, is if like take risks if you're young. Do things that inspire you, that you think are interesting, and don't just follow the money. And if you're good at what you do, hopefully the money and everything else will follow. I think that's great and very important to point out to young people. Maybe on the topic of startups and on the topic of taking risks. So you have a science background. You're the science side of startups. Maybe for people who have more of a business background, who want to be in startups that use technology, I think one good deal or one thing that's often done is to have like scientific advisors, and I know you've also served as a scientific advisor. Could you, one, talk about your experiences you had in that role, and then maybe also mention if you're a super tech savvy founder who's like looking for support, what should you look for? Who should you approach? What should you offer? What are your tips from a science person?
So yes, I've worked in startups in different roles as a founder in a number of startups, like in the one we did with Jürgen, but also in Artisense as a founder. But in many of them, I serve as advisor. And this ranges, computer vision and AI is a broad, area that has endless application. It ranges from medical, for example, I'm advisor to a company called Ablacon that one of my former PhD students created that looks at arrhythmia in the heart and tries to develop solutions for that. And that's gone quite well. I think commercially, probably the biggest success that I've been involved in as advisor is a company called Skydio that develops drones. And I remember it was here in this office that Adam Bry, then a PhD student at MIT, he gave a talk. He talked about drones, and we'd been working on autonomous drones a lot at the time, vision-based control of drones, things. And then he said, Daniel, I'm planning to create a startup to commercialize drones and drone technology. Would you be willing to serve as advisor to our company? Because you have the perfect background with your work. You know everything in this field. And I said, I'm happy to do that. And so I served as an advisor. Skydio, last I checked, was now valued at 1 billion. So this is, as I said, possibly one of the largest commercial successes that I've been involved in as an advisor. But there's many other companies. There's now a new one that I'm serving as advisor. It's called Deep Scenario, that they do traffic analysis from drones out of the air. To monitor traffic, cars, cyclists, pedestrians, everything, to get accurate understanding how humans drive, how humans behave in traffic. And that company recently raised a seed round as well successfully, and I helped them to set up the seed round to make sure everything goes as planned.
So what services do you provide, or how do you help the founders? Is it just your name that investors know, okay, they have contacts to people who are very knowledgeable in the field, or how do you help them? What do you do to help the companies, the startups you advise?
So the name definitely helps to raise capital, but also to find customers and to recruit talents. There's a lot of things that a startup needs to do. And typically recruiting top talents is easier if they know that I'm serving as advisor, etc. But also actually providing technological advice that I tell them how to solve different problems, what is the right computer vision technique out there, published possibly just a month ago to solve exactly the problem that they have, that they're facing. And this is what I do. But then also my general expertise with startups, how to set up the pitch deck so that the investors actually buy in, right? How to make sure that the investor sees who the customer is and what the revenue is and what the market size is. And a lot of these numbers, how to make a compelling pitch story. This is something I learned by doing, right? When we created Fablitech, the first company with Jürgen, I went on investor meetings and got awards for pitching, but I learned by doing, and I learned by iterating, and I had coaches from TU Munich who told me this is not a good pitch deck. You have to completely rewrite the story. I didn't know what the pitch was. I was an academic. I was used to giving at least half an hour talks, right? They don't want half an hour talk. They want a 1 minute or a 3 minute or maybe a 7 minute pitch, but not more, right? And you have to make it compelling, you have to make it convincing, and you have to address what the investors want to see. They want to see the revenues, but they also want to see that the company is scalable, the business model scales, things like that, right? And so I have that expertise and can bring it into startups to help them set up right, to help them design the pitch deck and make the story compelling.
So you seem very involved. How much time does it take you to advise a startup in a typical week, or is it very irregular?
It is irregular, but on average, I would say that I'm spending about 1 day a week on these activities. And indeed, from TU Munich, officially, I am allowed to spend 1 day a week. And this is very nice that the university allows me to engage in non-academic or non-university activities 1 day a week. And so this is, I would say, on average, the time I spend. In practice, I should say there are phases where it's super intense. I've been on a trip on the West Coast where we did pitches every single day for 2 weeks, and I was completely dead at the end of the 2 weeks because we saw on average 2 investment firms per day, right, pitching the story, etc. And I've been in London and Paris for investor pitches and all over the place, and I've seen kind of the main investment firms around the globe. But on average, it's 1 day a week because there's phases when there's less activity.
And how much of that day goes to each company? Because like you're working with several companies.
I think it depends on the needs of the companies, and this is a little bit also when I supervise my PhD students. I don't have a strict regime saying I spend 1 hour every week or every 2 weeks with each PhD student. It's very much a little bit on demand. Sometimes a student comes to my office, says, Daniel, can I talk to you? And then I say, yes, not now, but this afternoon or tomorrow. I typically, because it's on demand, I can typically offer my students a speaking slot within the next 2 or 3 days.
And that also goes for your startups.
And that also goes for my startups, exactly. And so I spread my time evenly when they have a need or when I feel they need input. Then I reach out, say, how about we discuss this, what's going on with the investor pitch? How about we do a rehearsal, etc.
And how many startups are you currently working with?
I don't know.
You don't know?
I don't know. I think maybe a handful.
A handful.
I would say a handful.
Okay. And so if you're deciding whether or not to work with a startup, what are you looking for in terms of what do you want to see in the startup so that you think it's fun and exciting for you to work with them? But also, what are you looking to get from the founders? Like, are you looking for equity or what is it?
So this is typical in a startup. Equity is the currency. Because startups don't have money. That's the notorious thing about a startup. Obviously, once you raise more than 4 million, in principle, you do have money. But in practice, you have to be careful how you spend the money because that defines your runway. If you blow it out of the window, then you have a short runway and then you might go insolvent. So you don't. So, money, no matter what investment you raise, is typically scarce. But what you have in abundant amount is equity, shares or ESOP, as it's often called for employees.
And how many percent does an advisor, when they join at an early stage, typically get?
So that depends. It's negotiable. It very much depends on how much time you invest also in the startup. It can range from, say, a per mil to multiple percentage. It depends on whether you're a co-founder or more just an advisor, and it depends on how much time you actually invest and how important and how valuable your investment is to the company.
And when a team of founders approaches you and asks you if you want to advise them, what are you looking for in the founders and what are you looking for in the project?
So in the founders, I look for people who have drive, who really have an idea what they want and have a clear business model, right? I've had students approach me, they wanted to create startups to scan business cards and orient them horizontally, right? And I told them, look, this is a simple problem, it's so easy to solve, there will be a technical solution in the next 12 months. I don't think it's worth creating a startup for this. And indeed, now every Android phone has that app inside. You can scan a business card, it finds it, it orients it, and done, right? So I don't know, I don't think that startup went anywhere. So I sometimes tell them, look, from a technology perspective, you can be scooped in a matter of 2 months because this is something that my students can code in an afternoon. So as soon as someone realizes what the problem is, you just need to find the affine distortion. That's a solved, academically solved problem. and it will sooner or later come into the smartphones as an add-on, and then you're out of the business, right? And so sometimes I don't join startups. I tell them, look, I don't think there is a future here. But other things, I like people who have ambition, who have drive, who have an understanding of what is the niche that their product goes in, how does it fit the needs of the customers, what is the market value, and if I see, and in addition, it should be technologically interesting. So if it's only computing an affine distortion for business cards, that's so trivial, I'm not interested in this also, right? So there must be a scientific component. So I would never serve as advisor for companies like Facebook, right? Because the technology I find is not my area. I don't find it interesting. Even if there is a big commercial value, it has to be interesting. This goes back to my background as a physicist and mathematician. If there is no interesting mathematics behind it, then I have more important things to do, right? And as I said, yes, I join. Equity is typically the currency, but I also, it's important, you as a company, equity is the currency, but you have to basically equip the key founders with significant equity. And so it's also important that I, as an advisor, do not take too big of an equity, because I am not the full-timer behind it who makes it take off, right? I can advise, I can consult, but the people who really make a startup take off are the main founders, right? And they should have significant equity to be motivated.
So you're looking for inspired, motivated, ambitious founders who have problems that are technologically challenging and exciting, but also founders who understand the market behind their product, who know where it's going.
And a lot of it is also communication skills. The startups I've been involved in, we had a number of really super communicative founders, because you have to, in this world, you have to be convincing. You have to convince the investor to buy in, you have to convince the customer to buy it, and you have to convince business partners to join forces, etc., to create joint activities, etc. So you have to have a lot of communication skills as well. And so there is a lot of skills that it takes to make a successful startup, but I have an eye for these, and I think I can see, as I said, if someone has the right skill set. And then I engage, and then I'm happy to support the startups and make sure they succeed.
So communication is a key skill. Being able to convince people is a key skill. This has been a great conversation. This has been super inspiring. Thank you so much. Before we end, I invite you to convince the listeners to read 3 books that you think are good. And the first book, I always ask for a book recommendation that is somehow related to your field of research. Mm-hmm. Do you have anything?
Yes. So the book, I thought about it, the book that brought me into computer vision in the first place is this book by my colleague and friend Joachim Weikert, my former co-advisor on anisotropic diffusion in image processing. It's a book which for the first time opened my eyes and showed me that you can model images with beautiful mathematics, with diffusion processes that were familiar to me as a physicist, but I never, had the idea that you can do image analysis, image denoising, and actually seeing them in action like that is amazing. And Joachim is an amazing writer. He's an amazing storyteller. He gives wonderful talks as well. He's a great teacher as well. And so this book is what basically drew me into, as a physicist with a diffusion background, into image processing.
So what would you say is the minimal required background, or what would you suggest people should have seen before reading this book?
So this book, you have to have a bit of a math or physics background to read it, but it's mathematics, it's on differential equations, partial differential equations, and it explains things very nicely. So if you have some math background, you should be able to understand.
So like students of math, physics, or engineering disciplines should be able to work with this and get a lot out of it.
Yes.
Wonderful. Thank you so much. So the next book I'm asking for is a book that is related to science, but not your specific field. So maybe something adjacent.
So something adjacent in not computer vision, For me, my heart has always been in mathematics. I love mathematics, from very early on in school, but also through college. I debated studying mathematics, but then focused on physics with a minor in mathematics, but got a bachelor in both physics and mathematics, and then moved on with theoretical physics. And so mathematics is for me the language of science. And for me, all of science is ultimately how to cast things into mathematical language, because that is what allows you to compute things, to derive predictions, quantitative predictions about things, etc. And one of the most beautiful books that I read during my studies in mathematics is this book by van der Waarden, Algebra. It's, algebra is maybe not the most fascinating field for many people in mathematics necessarily, but for me, this book was a real eye-opener. It's really beautifully written by someone with a very deep understanding of the topic.
What would you say here is the recommended background to read this?
Well,
is it a very introductory?
Read it even after a bachelor in mathematics. If you've studied some mathematics, you should be able to understand this, right? If you've had a little bit of linear algebra, maybe a little bit of background, then there's also a part 2. But this should be readable for someone with a basic math background.
So again, basic understanding of mathematics. Could you maybe in one sentence describe for people who don't have a math background, what is algebra? Very, very briefly.
I think this would go a little bit too far for this interview to explain what because algebra is a broad field and it would take a little bit too much time.
Okay, understand.
It is one of the classical domains of mathematics.
And probably a rather abstract part of mathematics. So finally, what is one book you recommend that has nothing to do with your field of research, or not necessarily?
So one book that I found very beautiful that I read in the last few years is a book by a new historicist by the name of Stephen Greenblatt, and it's called The Swerve. And he describes a phase in the history of mankind that I find one of the most interesting phases in humanity. And that is the Renaissance. And it is a phase that also plays a role for my research, interestingly, and a phase that I do mention in my talks, in my lectures every now and then. When I talk about the backgrounds of image analysis, computer vision, how cameras work, this is knowledge that the ancient Greeks already developed 2,000 years ago. They had so much knowledge about perspective projection. They had knowledge, about so many things that are central to computer vision, right? But then, and this is one of the most puzzling aspects in the history of mankind, a lot of this knowledge was lost for centuries, right? If you look at the Middle Ages, most people couldn't read, right? But they didn't have this knowledge. And if you look at paintings in the Middle Ages, all this sense of perspective is gone, right? It's completely flat. Art historians will tell you they weren't interested in painting realistic paintings. I would argue they didn't know how to do it also, right? And then something miraculous happened, then the Renaissance came about. And the question is, how did that come about? Who were the people who basically discovered the ancient scriptures that were lost but sleeping somewhere in libraries around the globe, in monasteries all over the world, manually copied by generations and generations of monks, right? They spent a lot of their time copying ancient scriptures that were then sleeping in these same libraries and not known to the broader world. And then there were people in the Renaissance period, and the way Stephen Greenblatt describes that in a very tangible, exciting way, how this monk moves around in Europe to try to disclose and discover ancient Greek scriptures and translate them or make them accessible to modern world. And that opened up, I think, a revolution for humanity. And this is all described in this book by Stephen Greenblatt called The Swerve.
Well, thank you so much. All of these books sound very interesting. And again, this was a great conversation. I think the listeners are all fascinated by your stories, by your research, but also what you did with startups. So thank you so much for taking the time.
Thank you, Friedrich. It was a pleasure. Thank you.
Thank you so much for listening to or watching the Thinkers and Makers podcast. You can support the project by clicking the links in the description and buying the books that Danny recommends. Trust me, they must be good. You can also like and subscribe to the podcast. Special thanks to Johannes Müller and Pierre Brechert, who encouraged me to start the podcast and also helped me reach out to Daniel Cremers. I'm also very indebted to the ETH Student Project House. They give me the infrastructure and support I need to make this project happen. Tune in again next week when I talk to Kim Kuipers, who's a professor of neuroscience at Maastricht University. Kim does research on how we can use psychedelics to treat mental diseases and illnesses that are very hard to treat otherwise, including depression and anxiety. Have a great week and see you next time.